Hi, welcome to our channel of IGNOU Audiobooks. Indira Gandhi National Open University, School of Continuing Education, Certificate Programs, Certificate in Nutrition and Child Care, CNCC, CNCC 1, Nutrition for the Community, BLOCK-6 Nutrition Programs, Unit-25 Assessment of Nutritional Status. 25.1 Introduction. Health and nutritional status of an individual depends on the food he eats. This is a fact and it must be evident to you from the study of nutrition so far. Another aspect that is crucial and should be of interest to us all is how to find out whether the individual is in a state of good nutrition or not. You may recall reading about the good signs of health in Unit 1, Block 1. Examination or appraisal of the individual according to these signs could be one way of assessing the nutritional status. What are the others? Collecting food intake data of individuals could be the other. Sometimes, you may remember being asked by your doctor to get your blood or urine sample examined for specific diagnosis. For example, measuring the level of hemoglobin, HB, in the blood or measuring the level of glucose in the urine. These tests also constitute the assessment of nutritional status. How? In this unit, we will learn about the various different methods and their application in assessing nutritional status of an individual or group of individuals in the community. How to measure growth, since growth is a measure of nutritional status. What are the specific signs and symptoms one should look for during assessment? How does measuring the constituents of body fluids, i.e., blood, urine, help in assessing nutritional status? How to collect food intake data? These are the other set of questions which this unit attempts to answer. Objectives. After studying this unit, you will be able to times describe the methods used in assessment of nutritional status and times discuss the relative significance of each methodist. 25.2 Methods of assessing nutritional status. How do we determine the nutritional status of individuals? Before we discuss the techniques, let us quickly recall the meaning of nutritional status. Nutritional status, we know, refers to the state of health of an individual as it is affected by the intake and utilization of nutrients. From this definition, it seems that evaluation of nutrient intake alone can help judge the nutritional status of individuals. Would you agree? Well, it is not all that simple. Consider the example of a child who is not growing adequately. The child's failure to achieve an adequate rate of growth, for instance, may be caused due to heredity factors, infections, other diseases, dietary lack, or any other factor. Hence, evaluating the food intake alone may not give sufficient evidence for judging the nutritional status. What might be helpful would be to put together information about the type of illness, if any, including the observable signs of ill health the child is suffering from, the level of nutrients and other substances in the blood and urine. This information, you would notice, would help confirm whether the growth failure is caused by inadequate nutrient intake or some other factor. Examining the child's food intake pattern, for example, may suggest the existence of nutritional deficiency but mirroring the particular nutrient or its compounds, concentration in the blood-urine may confirm the tentative diagnosis. Measuring the level of nutrients and other substances in the body fluid on one hand can indicate tissue depletion of nutrients before clinical signs are observable. On the other hand, a study of food intake pattern may strengthen the argument. From our discussion above, it is, therefore, evident that there is and can be no one simple procedure for assessing nutritional status, because a particular finding may be due to any of the several causes. A variety of standard assessment techniques may be used to determine nutritional status. There are 4 major methods used to assess nutritional status of individuals and population groups, which include anthropometric measurement, clinical method, biochemical analysis, Diet survey. What are these methods? What information do they provide? How and when to use these techniques in assessing nutritional status? These are some of the aspects discussed in the next section. Remember, each of these methods has an unique contribution as well as inherent limitations that needs to be considered in the interpretation of data, but taken together they can confirm suspicions and provide factual basis for corrective measures. We begin the study of the techniques with anthropometric measurements. 25.2.1 Anthropometric measurements. Anthropometric measures simply refer to the measurements of body size. You may recall reading earlier in Block 3 that measuring body weight and height provide useful data for analyzing growth and for determining body size and composition. Growth as measured in terms of weight for age or height for age reflects the sum total of what has occurred up to that point in time. Besides height and weight, measuring body circumference facilitates identification of the degree of body fat and the amount of lean body tissues, i.e., muscles in the body. It aids in the identification of PM and obesity, the four most commonly used and simple body measurements, which serve as good indicators of nutritional status, therefore, are times weight for age, times height for age, times arm circumference for age, times weight for height. This section presents a detailed study on these anthropometric measurements. A brief discussion on various other measurements, i.e., head circumference, chest circumference, and skin fold thickness, is also presented in Highlight 5, which will give a complete picture of anthropometric measurements and their role in assessing nutritional status. Before we begin, we would like to draw your attention to the fact that the use of anthropometric measurements, especially height and weight, depends on two factors: 1. Accurate age assessment, and 2. Appropriate normal values or standards for comparison. Accurate age assessment is necessary simply because the body measures, i.e., height, weight, body circumference, increase with age. If the correct age is not known, it might not be possible to have an accurate assessment. Furthermore, the use of body measurements become useful only if the actual measurements obtained on an individual are compared with known values or standards. What do we mean by standards? The average body measurements of well-nourished and healthy children belonging to the well-to-do societies who are medically and socially well protected are referred to A standards, and these values are used for the purpose of comparison. If the body measurements for age are comparable with those of well-to-do arid healthy children, the child is considered nutritionally healthy. Tables providing standard measurement values of well-nourished children are available. For example, Indian standards, data compiled by National Institute of Nutrition, NIN, and NCFLS. Standards, USA. We will be using NCHS, National Center for Health Statistics. Standards for comparison, since studies conducted in India have shown that at least until adolescence, the growth pattern of well-to-do Indian children is comparable with that of American children. Tables providing standard measurement values are given in Appendix 2 at the end of the block. With this knowledge, let us begin our study of anthropometric measures. A. Height for age. Length or height is a very reliable measure that reflects the total increase in size of the individual up to the moment it is determined and could indicate adequate nutritional status. For example, we know that normalia baby measures 50 centimeters at birth. This birth length increased to 75 centimeters at 1 year of age. By the age Of 4 years, the child is 100 centimeters tall. Thereafter, the child gains about 5 centimeters in height every year until the age of 10 years. Recording the height would, therefore, help us to know whether the child is growing normally and is in good health or not. But it is also important to note that height changes too slowly to be used by itself to detect changes in growth pattern within a short time interval. In other terms, it is not a very sensitive measure for short-duration malnutrition, i.e., the condition of the body resulting within a short time interval due to relative or absolute deficiency of one or more essential nutrients. Furthermore, height does not decrease and, therefore, cannot indicate a deterioration in health. Height for age, therefore, is only a measure of long duration malnutrition, i.e., the condition resulting from a relative or absolute deficiency of one or more nutrients over a very long period of time. Low height for age is indicative of stunting and of chronic malnutrition. Next, we come to the question how to measure height. A vertical measuring tape scale fixed on the wall can be used to record height of older children and adults as indicated in Figure 25.1a. Alternatively, height measurement can be taken against a wall, Figure 25.1b. The individual should stand with bare feet on a flat floor against a perpendicular wall with feet parallel and with heels, buttocks, shoulders and back of the head touching the wall. The head should be held erect and a mark should be made on the wall with a flat object touching the top of the head horizontally and its vertical edge flat against the wall. Height can then be measured using a good measuring tape. Figure 25.1 Height measurements. Look at the screen for table content. L in the case of infants, all IUII, LL1 to tilde et, Fig. 25.1c can be used. This is a specially prepared wooden scale on which the infant is made to lie down, with the head touching the fixed headpiece. The legs are extended fully by pressure on the knees and the movable sliding piece is allowed to touch the flat of the soles of the feet and the measurement is recorded. B. Weight for age. Weight for age is a commonly used indicator of body size, and it reflects the level of food intake. The relative change of weight with age is more rapid than that of height and is much more sensitive to changes in the growth pattern of the individual. Significant changes can be observed over periods of few days. Therefore, unlike height for age, weight for age is a very sensitive measure of short duration malnutrition. The weight of children should be recorded regularly to check if there is regular gain in weight. The weight recorded can then be compared with standard values or alternatively the weight can be plotted against age on a graph to see if the pattern of growth is normal by comparing it with the normal curve. We will learn more about this aspect later in this unit. L in the case of infants, all IUII, LL1 to tilde et, Fig. 25.1c can be used. This is a specially prepared wooden scale on which the infant is made to lie down, with the head touching the fixed head piece. The legs are extended fully by pressure on the knees and the movable sliding piece is allowed to touch the flat of the soles of the feet and the measurement is recorded. B. Weight for age. Weight for age is a commonly used indicator of body size, and it reflects the level of food intake. The relative change of weight with age is more rapid than that of height and is much more sensitive to changes in the growth pattern of the individual. Significant changes can be observed over periods of few days. Therefore, unlike height for age, weight for age is a very sensitive measure of short Duration malnutrition. The weight of children should be recorded regularly to check if there is regular gain in weight. The weight recorded can then be compared with standard values, or alternatively the weight can be plotted against age on a graph to see if the pattern of growth is normal by comparing it with the normal curve. We will learn more about this aspect later in this unit. Look at the screen for table content. Fig. 25.2 weight measurements. One can also use the ordinary weighing balance as shown in figure 25. To see to measure weight. But for measuring the weight of children using this balance, we need to be more careful. First, the weight of the mother and child together should be recorded. And then the mother should be weighed alone. The difference in the two weights is the weight of the child. This measure, however, may not give very accurate results. So it should be used with caution. C. Weight for height, by relating the weight 0 a child to its height or length, and OBJ-CTV week, 1 measure of the child's degree of thinness can be obtained. Weight for height. Basically, I is a very good index for short duration malnutrition. This measurement is of value especially in situations where C-ILD health services are not available to carry out periodic monitoring and children are seen irregularly, say once in a while. The measure has an added advantage that accurate age assessment is not required and therefore it is age independent and can be easily used in populations where the child's age is not known. A too low weight for height is called wasting. Weight for height standards are available, which are given in Appendix 2, Table 4. At the end of the block. You are listening to this audiobook on Audio Learn IGNOU. D. Mid-upper arm circumference, MUAC. The mid-upper arm circumference is an useful indicator of nutritional status of individuals and communities. How does this measure reflect the nutritional status of individuals is what we shall study first. Arm circumference, you might be aware, basically includes bone, fat and muscle. Fat and muscle, are the body's energy and protein reserves. These reserves are reduced in the body if the body does not absorb or take enough food, as appears in the case of protein energy malnutrition, thus resulting in reduced arm circumference. Arm circumference normally increase with age, but between 1 to 5 years it does not change much and remains fairly constant. At this time the baby fat is replaced by muscle. Measuring the arm circumference of this age group would, therefore, give a good idea whether the child is in good health or not. The mid-arm circumference for age of well-nourished Indian children is given in Table 3 in Appendix 2 at the end of the block. A measurement below 80% of the normal, i.e., less than 12.5 centimeters, indicates severe malnutrition, and a measure between 12.5 centimeters and 13.5 centimeters indicates moderate malnutrition. The MUAC is, therefore, an easy and useful measure for assessing thinness or muscle wasting in children in the age group 1 to 5 years. Like weight for height, this measure too has an advantage that one does not need to know the exact age of the child in order to know the nutritional status. We move with the assumption that the mid-arm circumference of children between the age 1 to 5 years remains fairly constant at about 15 to 16 centimeters. Any reduction in this measure is, therefore, indicative of advanced malnutrition. MUAC is of value particularly in field situations when weighing is impractical or not possible, yet one needs to identify children in greater need of nutritional assistance. It is used primarily as a screening tool to measure changes in broad categories, rather than for precise assessment. We come to the next crucial question, that is, how do we measure arm circumference? One can measure the roundness fatness of a child's arm using any ordinary measuring tape by placing it around the middle part of the child's left arm and recording the value. However, in the field situation, the arm circumference measurement is most commonly taken using a tricolored strip called the tricolor arm tape. The tricolored strip is a flexible but a non-stretchable plastic tape. A specimen tape is given in the margin alongside. The tape has three colors: red, yellow, green in that order at appropriate cutoff points. The red zone is 12.5 centimeters long, the yellow zone is 1 centimeter long, and the remaining portion is green. What do these colors on the tape indicate? This can be best understood by practically using the tape. Get hold of a child in the age group 1-5 years. Now place the tape around the middle part of the child's left upper arm. Next, put the red end beside the green or yellow part of the strip. See which color the red end comes opposite to. If the red end comes opposite to green, it indicates that the child is normal and healthy and getting enough food. Keep feeding the child enough food. If the red end of the strip comes opposite the yellow, it indicates that the child is moderately malnourished. The child needs more food every day. Give supplementary nutrition, providing 300 kcal and 8 to 10 gram protein to the child. Weigh this child every month. If the red end of the strip comes in red itself, it indicates the child is severely malnourished. The child needs more food. If he does not get enough food, he may die. Give double the amounts of supplementary food to the child. Feed the child at least 5 to 6 times a day. Weigh the child every month. Take advice of health staff. This exercise must have demonstrated how easy it is to assess the nutritional status of children using the MUAC tape and what corrective measures to take. This measurement is one of the commonly used measures in the field situation, especially in the Integrated Child Development Services Program. Under this program, MUAC tape is quite often used to screen normal children from moderately and severely malnourished children and provide supplementary nutrition to the malnourished children. So far we have studied about weight, height and arm circumference. Besides these measures, certain other measures are also useful in the assessment of nutritional status. An idea about some of these measures is given in Highlight 5. Highlight -5. Other anthropometric measures. Earlier in this block we talked about the height measurement as a means to note the gross increase in the size of the body. Height is a linear measurement. In addition to height, length, certain circumferences, particularly of the head and chest, are two other linear measurements which are useful to study the growth pattern in children. You have also studied about the arm circumference, which you may recall is a measure of the soft tissues in the body, namely muscle and fat. There is yet another measure used to study the soft tissue, particularly fat, which is called skin fold measurement. Let us get to know what are these measurements and how to record them. We begin with head circumference. A. Head circumference. The head circumference is mainly related to brain size. You would have noticed that the infants have a large head at birth as compared to the rest of the body. The head circumference increases rapidly during the first 6 months after birth, and thereafter, it increases slowly. The brain size, however, can vary with nutritional status, and the head circumference is slightly affected, especially in the second year of life in protein energy malnutrition. Measuring the head circumference, therefore, is a good indicator of nutritional status. How does 1. Measure the head circumference. An ordinary measuring tape can be used to measure head circumference as indicated in figure 25.3a. However, make sure that the tar-tilde-e used is narrow, less than 1 cm wide, flexible of non-stretch quality, preferably made of steel or fiberglass. The measurement should be taken carefully, ensuring that the greatest circumference of the head is measured.
Figure 25.3 Measurement of head and chest circumference. Look at the screen for table content. B. Chest circumference. It is a practical and useful indicator of growth in the second and perhaps the third year of life. The chest circumference measurement, along with the head circumference, is useful to detect malnutrition in children. At 6 months of age, you would notice that the head and the chest circumference of the infant are about the same. After this, the chest grows more rapidly as compared to the skull, as can be seen from figure 25.4. A chest/head circumference ratio of less than 1 taken between the ages of 6 months and 5 years would be indicative of malnutrition in children. Figure 25.4 Comparison of the head and chest circumference in the first 5 years. We could use the Cerner measuring tape used for measuring head circumference to measure the chest circumference. The measurement should be made at the nipple level of the chest, figure 25.3b, with the child preferably resting on the mother's lap. Avoid taking measurement when the child is crying, screaming or breathing irregularly. We could use the same measuring tape used for measuring head circumference to measure the chest circumference. The measurement should be made at the nipple level of the chest, with the child preferably resting on the mother's lap, figure 25.3b. Avoid taking measurement when the child is crying, screaming or breathing irregularly. C. Skin fold measurement. It is a simple means of measuring subcutaneous, a.e. fat under the skin, which is also known as skin fold thickness and, therefore, is an index of fat reserves in the body. Under conditions when there is insufficient intake of calories over a long period of time, there is reduction in the thickness of the fat layer under the skin, thus indicative of undernutrition. How do we measure skin fold thickness? Skin fold calipers like the one shown in figure 25.5 is used for measuring skin fold thickness. The best site for skin fold measurement, especially in children, is over the triceps, a muscle found in the upper arm region. The skin fold measurement requires more training and expertise than L1 measuring weight and height. Look at the screen for table content. Figure 25.5 Measuring skin fold thickness using calipers. The discussion above presented a detailed study of various anthropometric measurements that can be undertaken to assess nutritional status. Table 25.1 summarizes the above discussion and tabulates the specific body measurement in nutrition survey that can be used for different age groups. Table 25.1 Recommended body measurements in nutrition survey. Look at the screen for table content. After a detailed study of anthropometric measurements, let us now shift our attention to the clinical method of assessing nutritional status. What is clinical assessment? The discussion below will help you understand this concept. 25.2.2 Clinical method. Consider a situation where you come across an infant who is not growing well. His body weight is very low. There is tremendous muscle wasting and the infant is generally irritable. If you were asked to comment on the nutritional status of this infant, what would be your assessment? Yes, undoubtedly you would say that the child is in state of poor nutrition and is possibly suffering from marasmus. How did you come to this conclusion? Sure enough, you detected the obvious clinical signs/symptoms common to marasmus, i.e., muscle wasting, low body weight, irritability. Clinical examination, therefore, is one of the simplest methods to assess nutritional status. It involves looking for changes, clinical signs/symptoms, in the body, which are indicative of a particular deficiency. For example, you might look for bitot spots and night blindness in children to suggest the possibility of vitamin A deficiency. Paleness, lethargy in women to suggest the possibility of anemia. What is important here is to have knowledge about specific nutritional deficiency signs and symptoms and an observing eye to detect the same. With careful training, we can learn to recognize certain crucial clinical signs. What are the signs one should look for? Table 25.2 summarizes some signs which would help in clinical examination. You have already learnt about these signs earlier in Block 5. It is, however, important to remember that survey work based on clinical signs alone may not give a very true picture of the problem. A correlation with complete diet and medical history, a thorough physical examination, anthropometry, and biochemical testing is necessary for good assessment. For example, an individual who is not getting enough sleep, 6 to 8 hours daily, complain of irritability, lack of concentration, laziness. These symptoms are also characteristic of a continuing lack of iron in the diet. So correlating these clinical findings with biochemical tests, dietary survey will help lead to the correct diagnosis. What is biochemical assessment? What is its role in the assessment of the nutritional status of the community? We shall learn about these aspects in the next section. 25.2.3 Biochemical Assessment. Biochemical assessment deals with measuring the level of essential dietary constituents, nutrient concentration, metabolite, in the body fluids, blood and urine normally, which is helpful in evaluating the possibility of malnutrition. For example, a measure of the level of HB in the blood is helpful in evaluating the possibility of iron deficiency anemia. A measure of the level of thiamine in the urine reflects the intake of thiamine in the diet. A measure of the level of vitamin A in blood reflects intake and reserve of vitamin A in the body. How do biochemical tests help in the assessment of nutritional status? Biochemical assessment basically works on the principle that any variation in the quantity and composition of the diet is reflected by changes in the concentration of nutrients or their compounds in tissues and body fluids, and/or by appearance or disappearance of specific substances, i.e., metabolites. Measuring these essential dietary constituents would, therefore, help assess nutritional status. The following example will help us to understand this aspect. In the last section, you remember we considered the example of an individual complaining of lack of concentration, laziness, irritability. In such a case, measuring the level of HB in the blood would help relate the clinical findings to iron deficiency. If the level of HB falls below 14 mg/100 ml blood in males, it is indicative of iron deficiency manifesting as lethargy, irritability and lack of concentration. Biochemical assessment, therefore, is very useful for assessing nutritional status as well as for the purpose of diagnosis. Correlating clinical findings with biochemical tests can surely lead to right diagnosis. In this unit, our attempt has been only to help you understand how correlating biochemical tests with clinical findings help lead to correct diagnosis. No attempt has been made to discuss the various tests/techniques used in biochemical assessment, as this requires deeper knowledge and training, which is not within the scope of this unit. Next, let us discuss diet survey as a method of assessing nutritional status. 25.2.4 Diet survey. The term survey, you might be aware, commonly refers to the systematic inquiry into something. When a systematic inquiry into the food supplies and food consumption of individuals and population groups is made, we call it a diet survey. The dietary intake data can be collected covering a whole nation from families of different economic classes, or from individuals of special age group or occupation, depending on the need. What is the kind of information that can be obtained from diet surveys? This question surely is of interest to us. You may be surprised to know that information may range from a gross measure of intake such as the national per capita consumption of a commodity wheat, sugar, etc., or a very precise evaluation of an individual nutrient intake, such as the ILG of vitamin C or iron in the meal in a DES. The accuracy of the data, however, depends on the method used to collect the information. From this statement arises the next question, that is, what are the different methods used in diet surveys? There are a wide range of methods used in diet surveys. A list of these methods with a brief monty or about the nature of information obtained from each is presented in chart -1. A detailed study of each of these methods is 1/10 required at this stage, and also it is beyond the scope of this unit to develop this thought. What should be of interest to us at this stage is to have simple practical knowledge about diet surveys and, if required, be able to conduct a diet survey using one simple method. To help achieve this objective, here is a brief discussion on one of the most commonly used and simple method of collecting dietary intake data, namely the 24-hour recall method. Chart 1. Methods of diet survey. Methods of diet survey and nature of information obtained. 1. Agricultural data. Food balance sheet. Trend in food consumption of large population groups at national level can be identified. Gross estimate of agricultural production, food imports and exports. Agricultural methods can be made. The data obtained, however, is only a gross estimate. 2. Weighment method. Most accurate method for obtaining dietary intake data of individuals. In this case, all foods, liquids and solids consumed by an individual is carefully weighed near to 8 kg. Also, a record of rock waste, i.e., amount of food not eaten by the subject, is kept. Then through simple calculations, dietary intake of individual is worked out. 3. Food record or diary provides food consumption data of individuals. The subject has to keep a written record of all the foods and beverages ingested over a given period of time. Portion sizes are estimated using food models, and standard measuring instruments of food items are actually weighed. 4. Diet history yields a retrospective estimate of food and nutrient intake of an individual over a period of time. The period covered ranges back from 3 months to 1 year at the most. Information regarding food practice is obtained through interviews or questionnaires addressed to the individuals themselves or to some other person, for instance, the mother in the case of children. 5. 24-hour recall method, used in large-scale nutritional surveys to collect dietary intake data of individuals. The subject is asked to recall in as much detail as possible the food intake for the past 24 hours, by interview or by completing a questionnaire. The interview is conducted by trained personnel using food models as well as standard measuring instruments. 6. Food frequency. This consists of asking the individuals, by interview or by a checklist, how often, daily, monthly, weekly, specific foods are eaten. Usually, the foods are grouped into categories, based on similarity of nutritive value, function in the diet, etc., and the frequency with which these food groups are consumed is recorded, which is used as an index of diet pattern of population groups. The 24-hour recall. The 24-hour recall method is probably the most widely used method of dietary assessment. Under this method, the subject/individual is asked to recall/describe, in as much detail as possible, the food intake for the past 24 hours. The individual recalls what was eaten, how much food was eaten, how was the food prepared, when was it eaten, and other such details related to food intake. While conducting the survey, what we would need to do is to contact the housewife and ask her to recall amounts of foodstuffs used, preparations made and distributed to individual members in the family, to help the housewife recall this information. Standard measuring instruments like the cup, spoon, glass are used. Figure 25.6. Where can one get these standard measures from? Well, we need not worry on this account. You may recall that a set of standard measures have been provided in the practical kit. These measures may be used for the purpose. Illustration and caption. Figure 25.6 Standard measures used in diet survey. Look at the screen for table content. Simple guidelines on how to conduct the survey using these methods have been listed in Appendix 3A, which when followed will help you assess nutritional status of individuals and population groups. A schedule for 24-hour till-to-recall method of diet survey is attached for your information in Appendix 3B at the end of the block. A word of caution: the 24-hour recall i.e. dietary/intake data of one day is not very well suited for correlation with biochemical or clinical findings. When such analysis are required, repeated 24-hour recall, i.e. dietary intake data for 2 to 3 consecutive days may be administered. With the understanding of diet survey, our study of the assessment of nutritional status is complete. Is it so? Well, not really. A study of nutritional assessment cannot be complete without a discussion on growth monitoring. What is growth monitoring? Remember, while reading about weight for age as a tool of assessing nutritional status, in section 25.2.1 we talked about recording weight and plotting it against age on a graph to help visualize the pattern of growth. We were referring to growth monitoring then. Growth monitoring of children from birth to 5 years, by weight for age, is one of the important methods of assessing nutritional status of children and taking appropriate measures for reducing incidence of malnutrition. What is the concept of growth monitoring? How is it useful in promoting good health of children? What are the steps in growth monitoring? The subsequent section presents a detailed discussion on these aspects. 25.3 Growth monitoring. Growth, is the regular increase in the size or weight of living thing. The early years of childhood are the most rapid growth periods. If the child is growing, normally we say the child is healthy, but because of the rapid growth the child is also most vulnerable to factors like inadequate diet and illness, which may slow or stop growth. In other terms, growth faltering may occur. Growth faltering indicates that there is something wrong with the child, which needs to be detected and corrected. Monitoring or measuring the growth is, therefore, a good way of assessing whether the child is in good health or not. But how do we measure growth? You have learnt earlier in this block that the most accurate and sensitive measure of growth is weight gain. Weighing the child regularly would give a good idea of the growth pattern. This is the principle behind growth monitoring. Let us get to understand this concept. What is growth monitoring? Monitoring in a simple layman's terminology means keeping a regular track or check on something, like every week or every month. Keeping a regular track of the change in weight over a period of time, i.e., every month, can, therefore, be referred to as growth monitoring. From this statement it might however appear that growth monitoring is only an assessment, i.e., weighing, tool, but this is not true. Growth monitoring is the regular measurement, recording and interpretation of a child's growth change in order to counsel, act and follow up results. In other terms, assessment, weight, and action, consequence of results, are linked by relevant interpretation in growth monitoring. These activities are best described by the term growth monitoring and promotion, GMP. The term promotion has been added because monitoring alone emphasizes assessment rather than action. Growth monitoring has been defined in many ways. The Integrated Child Development Services (LCDs) program defines growth monitoring as under. Growth monitoring is a regular measurement of growth which enables mothers to visualize growth, or lack of it, and obtain specific, relevant, and practical guidance to ensure continued regular growth and health of children. You are listening to this audiobook on Audio Learn IGNOU. What growth monitoring is expected to do and how? In most developing countries, children suffer from malnutrition, which is associated with poverty, compounded by repeated infections, like diarrhea, measles, and illnesses. The resulting feature is weight loss or lack of weight gain. i.e., growth faltering. Growth faltering, therefore, can best be detected at an early phase through growth monitoring and promotion. The purpose of growth monitoring is to help identify the at-risk child, take action on the first sign of inadequate growth, and integrate nutrition intervention, breastfeeding, supplementary feeding, etc., with other health interventions, immunization, ORT, to restore health and proper growth of children. Growth monitoring is a preventive and promotive strategy aimed at action before malnutrition occurs. By creating concern and demand for growth and enabling it to be visualized, growth monitoring uses regular monitoring of growth to establish a regular, recurring, effective communication with each mother. In fact, it acts as a tool for health and nutrition education to mothers, thus promoting optimal health of the child. Now we come to the crucial question: how do we monitor growth? Let us consider. How do we monitor growth? You are aware that weighing is the usual assessment tool for monitoring growth. Alternatives to using weight includes other anthropometric measures such as arm circumference or clinical signs such as thinness. Whatever be the method used, remember it must be sensitive and specific enough to detect changes in growth and must be linked with appropriate interpretation and action. One such simple assessment tool is the growth chart. What is growth chart? You may recall reading about growth charts in Unit-24. Growth chart is primarily designed as a means of monitoring and interpreting changes in weight over time. The essential feature of a growth chart is a graph, figure 25.7, on which weight is plotted against age so that growth can be followed graphically in comparison with reference standards. Let us understand the growth chart. Observe the growth chart given in figure 25.7. On the extreme upper left-hand side you see a box. This is the information box, where the child's name, sex, father's/mother's name, etc. is filled. The growth chart has horizontal lines going side to side and vertical lines going top to bottom. The vertical line represent the age of the child and the horizontal line represent the weight. Along the y-axis is the weight written in kg. At the bottom of the chart are 5 steps, each of which represent 1 year in the child's life starting from 0 to 5 years. Each step is further subdivided into 12 lines which represent the 12 months of the year. The first box on the extreme left has a thick dark outline. This is for birth month and year of the child.
In addition, you would have noticed 4 curved lines on the growth chart. What do these lines indicate? These curved lines represent children in different nutritional grades. Children who are healthy with normal body weights, that is body weight equal to or above 80% value of standard, would usually fall above the top line labeled normal. If the child's weight falls below the first line, the child is considered undernourished. The lower the weight, the more undernourished the child. When the weight is between the top line and the second line, i.e., when weight is less than 80% and more than or equal to 70% value of standard, it would indicate the child is suffering from a grade/degree malnutrition. For example, at 4 years the child should weigh approximately 15 to 16 kilograms. If the actual weight is less than 13.4 kilograms, i.e., 80% of 16, or equal to 11.2 kilograms, i.e., 70% of 16, it would indicate that the child is suffering from grade 1 malnutrition. Figure 25.7 growth chart. Look at the screen for table content. When the weight is between the second and third line, weight between 70% and 60% value of standard, the child is in grade 2. When the weight is between the third and the fourth line, weighing between 60% and 50% value of standard, the child is in grade 3 malnutrition. When the weight falls below the fourth line, weight below 50% value of standard, it is a danger signal indicating the child is severely malnourished and in grade 4. WTH The understanding of the growth chart. Let us now move on to study the steps involved in plotting the growth chart. Steps in growth monitoring. The 5 steps involved in growth monitoring are:
Step 1. Determining correct age of child. Step 2. Accurate weighing of each child. Step 3. Plotting the weight accurately on the growth chart. Step 4. Interpreting the direction of the growth curve. Step 5. Analysis and follow-up action. Each of these steps are discussed in details below. 1. Determining the correct age. Growth monitoring, is based on comparing the weight of the child with his age. So the very first thing we need to do is to find out the age of the child. If the correct age is not known, it might not be possible to have an accurate growth chart. Therefore, knowing the correct age is essential to growth monitoring. How do we get to know the correct age of the child? Can you suggest? Yes, we could look at the records and of the child's birthday, month and year, with whom parents, or alternatively we can consult the local official register of birth with a village panchayat, in case of rural area, or the hospital card, in case of both urban and rural areas, depending on where the child was born. At times you might come across a child who does not have a birth record. So, then how would we estimate the age of this child? We can estimate age using a local events calendar. An example of such a local events calendar is given in Appendix 4. As the name suggests, a local events calendar is a record detailing the dates on which important events took place during the past 5 years in a specific area. For example, local festivals, phases of the moon, full moon, new moon, different seasons, general elections, flood or cyclone in the area, etc. By questioning the mother/family members regarding the season, crop harvests, events, festivals, etc. which occurred soon after or before the child was born, we can look up the local event calendar to find out the exact birth month. But remember, the calendar should be local, i.e., specific to the area, and should cover all events for the last 5 years of that area. 2. Accurate weighing of the child. Along with age, accurate weighing is also essential in growth monitoring. Measuring the weight gain of the child every month is a measure of growth. Hence, accurate and sensitive weighing scales should be used to weigh children. You may recall reading earlier in the block about using Salter weighing scales or beam balances to weigh children. Using whatever is easily available, accurately weigh the child. 3. Plotting the weight accurately on the growth chart. After determining the correct age and accurate weight of the child, the next step is to plot the same onto the growth chart. Let us see how it is done. First, write down the child's name, sex and other information asked for in the information box given in the growth chart. Figure 25.8, filling the monthly column in growth chart. Look at the screen for table content. Fill up the month and year box. To understand this better, let us suppose we are preparing the growth chart for Ravi. If we assume Ravi was born in February 1991, write February 91 in the first thickly outlined box, as indicated in figure 25, and the next box write March 91, and in the next April 91, and continue till you reach January 92. So far you have filled up the month and year for the first year box. Repeat the same procedure in the second year box. But remember to change the year. The marking will read February 92, March 92, January 93. Likewise, fill in all the monthly boxes for the 5 years. You may be wondering why we need to fill up the year and month boxes right in the beginning. This exercise, you would see, will be helpful later while plotting. With this spade work done, let us now learn how to plot the weight taken every month on the growth chart. Figure 25.9 shows the growth chart of Ravi. Ravi, we know, was born in February 91. He weighed 4.0 kilograms in March 91, i.e., at 1 month of age. Write the weight below the box for March 91. Now to plot this weight on the growth chart, Move your finger up the March 91 column until you come to the solid line which represents 4.0 kilograms. Weight. Make a dot in the center of the column as indicated in the figure and encircle it. Next we move to the second month. In April, Ravi weighed 4.5 kilograms. In the same fashion as described above, write the weight below the box for April 91. Then move up your finger up the April 91 column until you reach the 4.5 kilograms dotted line. Make a dot in the center of the column and encircle it. Now connect this dot with a dot made on the chart for the previous month by drawing a line. This line is called the growth curve. By plotting Ravi's weight every month on the chart, the growth curve can be determined. Figure 25.9. Plotting weight on the growth chart. Look at the screen for table content. Interpreting the direction of the growth curve, the data plotted on the growth chart provides useful information for recognizing whether the child is growing properly or not. How? Let us understand. In the last step we saw how connecting the dots creates the growth curve which makes growth visible. It is, in fact, the direction of the line, growth curve, which is most important to interpret and discuss. Let us understand this concept taking few examples. The first example is of Ravi. Look at the margin illustration. It shows the growth curve of Ravi. A clear look at the growth curve shows that Ravi had a steady weight gain per month. This weight gain is adequate for his age, and the growth curve is moving in an upward direction. What can one interpret from this upward growth curve? An upward growth curve indicates that Ravi is gaining weight and is growing and is healthy. Let us now consider the example of Meena. From the growth chart of Meena given in the margin alongside, it can be seen that from March to July, there was a steady weight gain and the direction of the curve is upwards. However, after July, the growth curve is flat. What does it indicate? A flat growth curve indicates that Meena has not gained weight in that period, which means no growth. In other words, faltering growth. A flat growth curve is an indication that there is something wrong with Meena. The last example is of Shamu. The growth chart of Shamu, given in the margin alongside, shows that he was growing well from February to May. The direction of growth curve is upwards. After May till July, the direction of the growth curve is flat and the rate of growth has slowed down. After July, however, the direction of the growth curve is downward. What does this indicate? A downward growth curve indicates Fiat Shamu has lost weight, which is a SOCE0/grade concern. It represents that Shamu is not growing well and is possibly suffering from some illness. So what we need to do next is to find why Shamu is losing weight and take appropriate action. From our discussion above, it can be summarized that depending on the patterns of monthly growth of a child, the direction of the growth curve may be upward, flat or downwards. An upward growth curve indicates that the child is growing and is healthy. A flat growth curve indicates no weight gain, which is no good and requires attention, and a downward growth curve indicates loss of weight, which is a matter of concern and requires prompt action. Another aspect that needs interpretation is the nutritional grade the curve falls in. You are aware that the growth chart has 4 lines dividing the chart into nutritional grades. We need to check the position of the growth curve in relation to these grades. The curve should move in the upward direction towards the area called normal. If the curve falls below the normal line, it indicates that the child is undernourished and in need of help. Lower the position of the curve, the higher the degree of malnourishment. Plotting weight on the growth chart, therefore, helps to determine the grade of malnutrition of the child. Note: remember, no matter in which grade the child is in, it is the weight gain each month, indicated by an upward curve, which is important. A child who is not gaining weight every month, no matter what nutritional grade he or she is in, needs attention. The next important task in growth monitoring is to analyze the pattern of growth and take appropriate action. as is discussed in the following step. 5. Analysis and follow-up action. After plotting and determining the trend of the growth curve, whether the child is growing normally or not, the last and the most important step of growth monitoring is analysis, i.e., to find out what has happened to the child during the last month is 0. Make the child's growth pattern happen that way and take remedial action. For example, if the child's growth curve is flat or downward, find out from the mother what has happened to the child in the last month which has led to growth faltering. There can be many different reasons for poor growth, namely an episode of illness such as diarrhea, measles, fever, cold, cough, etc., or just plain unwillingness on the part of the child to eat anything, or delayed introduction of supplementary foods, etc. Find out from the mother the exact reason which caused poor growth in this child at this very time. Suppose if the mother describes an illness, next ask what she did for the child. Did she provide proper treatment for the illness? Did she continue feeding during illness? Did she give the child extra food to eat when the illness was over? Information on these aspects will be useful in planning specific remedial action which, when followed, will promote child's growth. This task may seem simple, but you have to take extra care to seek full participation of the mothers in this respect, i.e., in the recognition of growth faltering and the action she can take to correct it. Show the growth chart to the mother. Explain the growth curve. Discuss the growth trend with her. Find out what has happened to the child and accordingly plan the specific actions that she can take to promote health. For instance, if the child had diarrhea, ask the mother if she gave the child adequate fluids to drink tea or prevent dehydration. Make sure that she understands how to make and use oral rehydration mixture and the importance of continued feeding even when the child is sick. If she has withheld the food to the child during illness, explain to her, showing the growth curve, how this has caused the growth to falter or go downwards. Impress upon her to give extra food to the child each day so that the child recovers the lost growth and is on the road to good health. On the other hand, if growth is favorable, as indicated by an upward growth curve, what are we expected to do? Once again, the principle is the same. Show THC growth curve to the mother and tell her this is good. Next, find out what factors during the last few months have contributed towards the child's growth being so good. Applaud the mother and encourage her to continue following same child rearing practices. From our discussion above, it must be evident that measurement, i.e., monitoring, must always be followed by action, i.e., promotion. It is only through interpretation and relevant action one can help support the mother whose child is growing adequately and assist her when faltering occur. Data plotted on a growth chart also provides an excellent base for analyzing and identifying beneficiaries, children, for supplementary nutrition under the government's feeding programs, especially the ICDS. Let us consider children who have not gained weight for 3 consecutive months are given supplementary food, providing 300 kilocalories and 8 kg protein. Children whose weight are in grade 2 of malnutrition on the growth chart are also given 1 helping of supplementary feeding. Children who are in grade 3 and 4 of malnutrition are given double quantities of supplementary food at the Anganwadi in addition to being referred to the primary health center, PHC 25.4. Let us sum up. In this unit we learnt about the different techniques PSTD to assess nutritional status, namely anthropometric measurements, clinical method, biochemical assessment, diet survey and growth monitoring. Body measurements or anthropometric measurements we learnt are the most simple and widely used method to assess nutritional status of different population groups, especially children. Measuring parameters like weight for age, height for age, mid-upper arm circumference and comparing the values with standards give a good indication whether a child is malnourished or normal. Clinical examination, on the other hand, is based on the principle of recognizing certain physical signs in the body which are indicative of particular deficiency. This method of assessment requires specific knowledge regarding the various nutrition deficiency diseases and their clinical signs. With careful training, one can learn to recognize these crucial clinical signs and assess the nutritional status. Biochemical assessment deals with measuring the level of essential dietary constituents in the body fluids, which is helpful in evaluating the possibility of malnutrition. This technique is very specific and usually medical trained people undertake this job. Diet survey is the technique used to collect data on supplies and intake of foodstuffs at different levels, namely national, regional, family and individual. The 24-hour recall method has been described in same details with simple guidelines provided for collection of data. Growth monitoring is a process of sequential measurements for the assessment of physical growth and development of the child. The process involves regular weighing for early identification of growth faltering with a pre-prior and prompt follow-up action. Thank you for watching. We will see you in the next video with the next chapter.